Okay, so AMCs are coming closer, and let's review some algebra that will help you qualify for AME and beyond. So first up is some factorizations. So a squared minus b squared is equal to a minus b times a plus b for any numbers a and b. This is called difference of squares. And a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. This is called difference of this is called difference of cubes. And a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. And these can be easily verified by expanding it out. And remembering these formulas is crucial for scoring well on the AMCs. So let's see an example. So how do we factor a to the 4 minus b to the 4 using these? So first off, we notice that this equals to a squared squared minus b squared squared. So then we can apply difference of squares. So that means that this equals to a squared minus b squared times a squared plus b squared. But then we can factor this again, and that by difference of squares. That equals to this. So then this is the factorization. Okay, so now let's move on to some examples sourced from past AMCs. So now let's do this one. The positive difference between a pair of primes is equal to 2, and the positive difference between the cubes of the two primes is 31106. What is the sum of the digits of the least prime that is greater than those two primes? Okay, so let's just say like the prime p and p is less than p. Doesn't really matter. So that means that p minus q is equal to 2, and we spot the difference of cubes factors. Plus pq plus q squared. That p minus q is 2. So that means that this is 31106 divided by 2, which is going to be 31106 divided by 2, which is going to be equal to 15000 plus 553, which equals to 15553. Okay, so we know that p squared plus pq plus q squared equals 15553. But now let's use this condition. And so then we know that q is equal to p plus 2. So then let's try rewriting q equals to p plus 2. That means that p squared plus p times p plus 2 plus p plus 2 squared equals to 15553. Okay, so this is progress, and we just need to solve for p now. So let's clear this, and let's move this to top. So now this is pretty simple to expand, because this equals to p squared plus 2p plus p squared plus 4p plus 4. And that equals 15553. So this equals to 3p squared plus 6p is equal to 15549. And both of these are divisible by 3, so then we can divide by 3. So then p squared plus 2p is equal to, and 15549 divided by 3 equals to 5183. Yeah, it does. So p squared plus 2p, that looks a little bit like a perfect square. So let's try adding 1 to both sides to make it really a perfect square. And then we recognize that factorization is p plus 1 squared equals 5184. So now we can find p by taking the square root of 5184. And so like a trick to estimate it is that we know that it's more than 70, but it's less than 75 because 75 squared is by the ending in 5 trick. 75 squared equals to 5625 or something like that. But that's clearly more than 5184. So we know that must be even, so it's either 72 or 74, and it's going to be 72. So that means that P is 71. So that means that P is 71, and then P plus 2, which is Q, is 73. And the sum of the least prime that is greater than both these two is 79. So this is our answer. Okay, let's move on to the next problem. What is the value of this thing? So we could just write it all out, but let's try to optimize it. So let's just look at the denominator first. So right away we notice the sum of the difference of squares factorization, and that is just 1 plus 1 over 3 times 1 minus 1 over 5 times 1 plus 1 over 5 times 1 minus 1 over 7 times 1 plus 1 over 7 by difference of squares factorization, because 1 is also 1 squared, and 1 over 7 squared is 1/7 squared. And then we want 1 plus 1/3 times 1 plus 1/5 times 1 plus 1/7. And now we spot the common terms, because these terms are also in the numerator. So we can just take them, so then we can divide the numerator and denominator by the square root of the product of those terms. So we can divide them by this. So if we divide them by that, then we can just take them out of the denominator, and then we just square root the numerator. So it just, this now. And now this looks a lot more manageable to just expand. So if we expand it, the numerator becomes the square, let's just put the square root over everything. So then it becomes 4/3 times 6/5 times 8/7 over 2/3 times 4/5 times 6/7. And so then we know that all the denominators cancel, these cancel, and then we're just left with 2. So that's the answer. Next problem. Suppose that real number x satisfies this. What is the value of this? Okay, so it looks like these two are the numbers that, when multiplied together, form a difference of squares. So let's try that. Let's just say that the thing that we're trying to find is p, for example. Actually, no, because that represents prime. Let's just say it's a. So if we multiply them, then we get that 3 times a is equal to square root of 49 minus x squared plus the square root of 25 minus x squared times the square root of 49 minus x squared minus the square root of 25 minus x squared. So this is the difference of squares factorization. And this side equals to square root of 49 minus x squared, which is just 49 minus x squared, and then minus 25 minus x squared. And this equals to 24. So therefore, a is equal to 8. Next problem. So now we're going to cover Vieta's formulas, which are also extremely important when solving AMC problems and AME problems, etc. So let's just imagine that you have a polynomial. Let's start with quadratic, but we'll see how it generalizes. So for example, let's just say it's x squared minus 6x plus 26 equals 0. And let's just say the numbers r and s are solutions, or they're actually called roots. So by Vieta's formulas, r plus s equals 6 and rs equals 26. And that's because the constant, let's just add the number 1 here so it's less confusing. So remember that it's just 1x squared. So then in the quadratic case, we get r plus s is equal to negative of, remember the negative, and then it's just going to be negative 6 over 1. And the negative 6 comes from this coefficient of the x term, and the 1 comes from the coefficient of the x squared term. And this equals 6. And r times s is equal to this, the 26, the constant term, over the 1. So then it's just going to be 26 over 1, which equals 26. Notice that there's no negative on the rs, but there is a negative on the r plus s. So in this case, we'll get these relations. Okay, so now, what if we do a cubic, for example? So let's just say that we have a polynomial 2x cubed plus 6x squared plus 8x minus 10. No, minus 11. And we wish to find let's just say the roots of this, the solutions are r, s, and t. Let's try to find r plus s plus t. So it's going to be negative, always, and then it's going to be this term divided by this term, which is going to be 6 over 2, which equals to negative 3. So the sum of the roots in this case is negative 3. And the product of the roots, in this case, so let's figure out why we need a negative for some things and not for others. So let's consider rs plus st plus tr. So this equals to, we didn't have this because we used to only have 2 roots, but this equals to this 8 over this 2. And notice that this one, there's no negative. And the signs alternate. So that means that for rst, there is going to be negative, and it's going to be negative of negative 11 over 2. So negative of negative 11 over 2, and that just equals to 11 over 2. So then these are the relations. For degree 4, then we'll have, let's just say the roots are a, b, c, and d, and a plus b plus c plus d is equal to the coefficient of this term divided by this coefficient and negative of that, and ab plus bc plus ca plus ad plus bd plus cd, basically the sums of the products, is going to be equal to this term divided by this term with no negative. And then we also have this. Which one am I missing? Yeah, ACD. And these, and then this, that would be this term, which is not here because in the quarter case it would be like this, the x term, and that would be a negative of that term, that coefficient divided by the 2 at the front. And then ABCD, that's there's no negative again, and then we have that. So those are Vieta's relations. So let's try applying it to problem. So the roots of a polynomial 10x cubed minus 39x squared plus 29x minus 6 are the height, length, and width of rectangular box. Write rectangular prism. A new rectangular box is formed by lengthening each edge of the original box by 2 units. What is the volume of the new box? So let's just say that the roots of that polynomial are r, s, and t. And so if we lengthen all the edges by 2 units, this looks easy to expand. It just rst plus 2 times rs plus st plus 2tr each of these using Vieta's. R times S times T, well, that's just going to be negative of negative 6 over 10, which is just 3/5. So this equals 3/5. This RS plus ST plus TR is just 29 over 10. And then if we doubled it, then we'll get 29 over 5. And then R plus S plus T is just 39 over 10. And if we, then it becomes 78 over 5. So we want to find this plus this plus this plus 8. And this equals to 32 over 5 plus 78 over 5 plus 8, which equals to 110 over 5 plus 8, which equals to 30. Okay, so remember whenever you encounter an AMC problem, that obviously you need to make sure it can be applicable, but you should remember these formulas and remember how to apply them, which might be more important. So don't just apply the formulas blindly. If you like this video, please like and subscribe. Thank you.